section today, 4+, because it's an additional section in Chapter 4 to help us be successful. This is simplifying radicals. So first thing I want to talk about is reminding you how we simplify radicals. And then we can add some of the other fun stuff to the radical. All right? I want to remind you that when you simplify radicals, you want to find pairs that come out as a single number. Okay? So we're looking for pairs to come out as a single number. So a lot of times, I said before, you need a friend to go out to the party and you're going out as one group, right? Same idea here. So again, starting pretty easy. Let's say I have the square root of 50. 50 can break down into 25 and 2. And 25 breaks down into 5 and 5. And I would cross out the 25 so you don't get mixed up, right? So, what number has a friend out of those three that doesn't? The 5. The 5 gets to come out to the party. 2 stays home, exactly. Okay, good. Good. That's good. So today's going to be easy. All right, let's try another one. But I'm going to make it just a touch harder. Let's do the square root of, let's go 72. So there are so many different ways to break this 72 down, right? So Emma, give me one way. How do you want to break 72 down? 8 and 9. All right, 8 and 9. 8 breaks down into 2 and 4. And I'm going to cross out that 8. 9 breaks down into 3 and 3. Whoops. And I'm going to cross out the 9. And what other number still breaks down further? 4. Okay. Which is a 2 and 2. All right. Yep. So we have one group of 2s that's coming out, one group of 6s that are coming out, and there is a 2 left behind. Or one group of 3s. And remember, one of the things I always said before is when 2 numbers are going out to the party, it multiplies the fun, right? More the merrier. So we get 2 times 3 is 6, and left at home is that other little 2. All right? All right, how about 18x to the third y squared? All right, so let's start with the number. 18 breaks down into 2 times 9. 9 breaks down into 3 and 3, right? Technically, the x's, we have 1, 2, 3 x's, and we have 2 y's. So we have one group of 3s, we have one group of x's, and we have one group of y's. Ooh, close. They come up as one group, 3xy. And then staying at home is the 2 and an x. All right. Let's do another one. If I have a number already on the outside, so the party's already started. I don't know. Pre-gaming, okay. Let's go 150x to the fourth. Okay. So I'm going to break down 150 into what and what? 50 and 3. All right, 50 and 3. 50 breaks down into 25. Okay, and 25 is 5 and 5. And of course, I have 1, 2, 3, 4 x's. All right, I have a group of 5s that get to go out to the party. So what number am I going to have on the outside? 15, because the party's already started, right? So it's got to multiply the fun. Good. X squared, and what is staying home? Correct. 6. We have both a 2 and a 3 at home. Well, we're going to times them back together so they can have their fun too, right? Do we have questions on the basic idea of this? Okay. So I'm going to have to take it a little bit further. I'm going to actually get into some examples. All right? And then we got to get into dividing ones. We haven't done any dividing yet. All right. So here we go. Example number 1. Simplify. And let's start by simplifying negative 3 square root 32. Preston, what do you want to break 32 down into? 8 and 4, all right? All right, Corbin, what do you want to do now? Okay. 2 and 4. Okay. Now, Preston, go ahead with your question. Okay. So at this point, we can do a couple things. I want to just point it out. We can break these 4s down, but then you're going to have 2 groups of 2 that come out as 4 anyway, right? So since we have a group of 4s, we can actually stop right there.
That was my question. I just didn't want to feel stupid.
Oh, no. That's one of the reasons I did this. All right, so that group of 4s are coming out. And when it comes out and multiplies with a negative 3, we get negative 12 square root. And what's staying home? That little 2. All right, here's example number 2. Simplify. Let's go with negative 4 square root 200 x squared y squared. Okay, 102. Okay. Now what do you want to do? 10 and 10. See, by doing 10 and 10, we've got a pair, don't we? You can go 50 and 2. You just got to keep going then, which is fine. Yeah. But then 50 would break down into 2 and 25. Yes. All right, so we have a group of 10s that are coming out. So that's going to give us negative 40 on the outside. What number is staying home? Okay. Tell me about x squared. Yeah, that's x and x, so it's one group of x's coming out. What about y squared? Correct. Very good. All right. So when it's simplifying, it's pretty straightforward, right? We've got to talk about dividing. We've got to. So, dividing radicals. Step 1. Reduce the fraction. If possible. Step 2. Simplify the top and bottom. Step 3. Rationalize if needed. Rationalize is if there is a square root in the denominator. We rationalize, and we're going to talk about that. 4, reduce if needed. first I want to talk about the special rationalize thing. And you guys have done this before. You did it in Algebra 1. You did it in geometry. So I know you know how to rationalize. If I have 1 over the square root of 5, I cannot have a square root of 5 in the denominator. It's against the math gods. Okay? So to get rid of that, we have to multiply by the square root of 5. But whatever we do to the bottom, we also have to do to the top to keep it even. Yes? Lots of different mathematicians throughout history. All right, so on the top, it is 1 times the square root of 5, or the square root of 5. On the bottom, square root of 5 times the square root of 5 is really the square root of 25, which equals 5. Right? If you multiply these two together, the square root of 5 times the square root of 5, you just get 5. Okay? So let's say I have 1 over the square root of 3. Right. So I have to? Correct. Correct. So be square root 3 over 3. You remember doing this? Of course it got harder. Gage, you still with us? Okay. All right. So let's do one more. What if I had 2 square root 3 over the square root of 2? I cannot have a square root in the denominator. So we rationalize. We have to times by the square root of 2. If I times the bottom by the square root of 2, I times the top by the square root of 2. On the top, 2 square root 3 times square root 2. You multiply your outsides, 2 times 1, and you multiply your insides, 3 times 2. On the bottom, square root of 2 times the square root of 2 is? Okay? And remember, our last step said to reduce if needed. What do you see will cancel here? The 2's. Correct. Okay? That's rationalizing. All right, so let's get into a couple more examples. All right, I'm on example what? 4? 3? Example 3. Simplify. Let's go with the square root of 4 over 12. All right, so the very first step, gentlemen, the very first step was to reduce the fraction, right? So I could actually reduce this fraction on the inside. So this becomes the square root of 1 over 3, right? Okay, now this technically is the square root of 1 over the square root of 3. What is the square root of 1? That's just 1, right? So I have 1 over the square root of 3, which Preston's right, can't happen, so we have to? Yes, rationalize. Good job. Rationalize times by the square root of 3. So 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is just 3. All right. Example number 4. Okay. Can I reduce that fraction? No, I can't. So then I split it up. I have the square root of 12 over the square root of x squared. Can I simplify the square root of 12? 6 and 2. So this goes down into 6 and 2. And 6 is 3 and 2. So what number gets to come out? And what stays home? A 3. What about in the denominator? Can I simplify that? Wait, I just wrote that backward. Oh, no. I wrote it right. Never mind. Sorry. And then on the bottom, it's just going to be x. Okay? So now, do I have to rationalize? Do I have to reduce again? So I'm done. Example number 5. Let's go with okay, what's the very first thing we should do? Thank you, Libby. Reduce the fraction. What goes into both the top and the bottom? Definitely 4, right? So this reduces to 50 over 7, right? Okay, now we break this into the square root of 50 over the square root of 7. 50 breaks down into 25 times 2, and that's 5 times 5. So the top is actually what? Okay, can I simplify the square root of 7? Okay, so now I'm to step 3, where I have to rationalize. So I times both the top and the bottom by the square root of 7. On the top, you multiply your outsides. 5 times 1 is 5. And you multiply your insides. 2 times 7 is 14. On the bottom, 7. Okay? That's a great question. That's why I did this one. When you are reducing it or simplifying it, this 7's on the outside. It cannot simplify with something on the inside. It's kind of like they're in jail. You can't break them out of there. It's got to be in jail to spend time with them. Okay? So, you cannot reduce this 7 with that 14. One's in, one's out. All right? All right, last example. Yeah, that's a 12x on the bottom, yes. All right, so what do you think we should do first here? Negative 3 to the 4th power? Okay, negative 3 to the 4th power is actually 81. So I have 81 x to the 3rd over 12x. Now what's actually our first step when we go to do this? Reduce the fraction. Okay, so what goes into both 81 and 12? Okay, 3 goes into 12 4 times. 3 goes into 81 27 times. What about the x's? Can I reduce the x's? Yes. Where are there more x's? On the top, how many more are there? So this whole one cancels, and this becomes a 2. So right now I have the square root of 27x squared over 4. Is everybody good with that step? We just reduced the fraction. All right. So now this becomes square root of 27x squared over the square root of 4. On the top, we need to simplify that. The square root of 27, 3 and 9. Good. 3 on the inside, 3 on the outside. Good. X on the outside. What about square root of 4? 2 and 2, so it's just 2. And you're done. Yes. Okay. So you are doing on page 225, and again, this is like a side thing, making sure that we remember how to do it all before we get into the next section. Okay. So on page 225, we're doing 1 to 16 all.